Okay, statistics. Problem number 1. A set of data relates the annual salary and previous performance rating. So y over x, let's compare them, y over x. This is the salary raise compared with previous rating. Okay? And that is the slope, okay? So it says the line of best fit is y equals 1400 plus 2000x. I personally prefer to write it this way and not breaking any rules by doing it that way, okay? Keep in mind that with the linear equation, even though this is stats, that is the starting point, okay? In other words, at x equals 0. And that right there, 2,000, which is 2,000 over 1, that's your slope, which is also the rate of change. Rate of change, which is that. How much your salary changes based on your previous rating, okay? Basically, I think what it's saying here, and let's just assume that you can have a negative rating, meaning you didn't do well last year, and you can have a positive rating, okay? Looks like, let's just say each of these is thousands, and this is your salary raise. And then these are your performance ratings. I guess a positive could mean like positive 1, positive 2, positive 3, positive 4. These are improvements. And if you go negative, that means you have not improved this year. You've actually done worse, okay? So looking at that, what this is saying is that as your performance rating increases by just 1, you get a $2,000 raise. Furthermore, it says you automatically get a $1,400 raise no matter what. So it starts at $1,400. That means your raise. And for every 1 that you go over, you get to go up $2,000. So if you go up 1, $2,000. And for every 1 you go down, I guess presumably you could actually get a negative raise, meaning you lose money that year. So let's look at these solutions. It says, which of the following is not correct, which means you have to read all 4 of them and make sure that you find the one that's not correct. Keep in mind, too, that with statistics, much like a language arts test, you're looking for the most correct, or in this case, the most incorrect, because there may be some that are kind of incorrect, because statistics is inexact. So for A, for each increase of 1 point in performance, the raise will increase on average by $2,000. I think that's true. I think I'm going to write this, probably, or maybe the word predicted, because this is a correlation, okay? This means that there were people who received raises and who received pay cuts. Their dots are all over the place, okay? This line happens to be the one that sort of straddles all of them the best, okay? So it's the line of best fit. But it doesn't necessarily mean that you'll definitely get a $2,000 raise, and so that's an important thing to remember. Probably, predicted. But it's still not untrue. It's pretty true. Part B, a rating of 0 will give a predicted raise of $1,400. Yeah, because it says that at 0, so in other words, you didn't change at all, you still get a $1,400 raise. I guess that's a cost of living, okay? But also, probably, predicted. I would imagine there's someone who did not get a raise. Okay, part C, a rating of 0 will give a predicted raise of $2,000. Well, no, if you think about it, a rating of 0 would put a 0 in here for X, which would negate the $2,000 completely in that function, right? And so you don't get a raise except of the $1,400 if you get a 0. That one is not true, but let's read all of them just to be sure. The correlation for this relationship is positive. Well, yeah, it's headed uphill from left to right in the direction that you read. It is positive, so yeah. Remember what you're looking for in this one is the one that is the least true, because they're looking for the one that is not true. That answer is C. Okay, so you're just interpreting the slope in terms of the context. So we're going to go to your redemption problem for the first statistics. This is a maze experiment talking about the number of previous attempts that you've made at the maze and how that affects the amount of time it takes you to complete it. And the equation, which is probably hard to read, is y equals negative 6x plus 99. Okay? So, these students are looking at a paper and pencil maze multiple times. They do it again and again and again, and they're looking to see how the amount of time it takes is affected. A linear model is that negative 6x plus 99. Okay? Now, I'm going to zoom in on this. So, move this up. Let me just get rid of this. All right. Now let's make this bigger because you need to be able to read what this says. Interpret the slope in the context of the problem. And again, let me just, y equals negative 6x plus 99. Okay? So the slope, negative 6 over 1x plus 99. Okay? Remember what the axes labels were and take a look at A, B, C, D and tell which one is the best interpretation of the slope. Good luck.